All right, welcome to Unit 2. ¿Qué tal? Bienvenidos. I've been learning Spanish little bit by little bit. Okay, coming back. Reciprocals. Recall. What is the reciprocal of cosecant theta? What is cosecant theta? Cosecant theta is reciprocal of sine theta. Likewise, reciprocal of sine theta is cosecant theta. Remember this, right? So when cosecant and sine, when you multiply, becomes 1. Reciprocal is, for an example, reciprocal of P is 1 over P, right? When you multiply P with 1 over P, it becomes 1. This is multiplicative identity of P. Likewise, multiplicative identity of 1 by P is P. P is 1 by P. Let's remember that. Likewise, now, secant and cosecant, when you multiply, becomes 1. Tan and cot multiply becomes 1. Remember this, right? Cot is reciprocal of tan. Now, recall the Pythagoras theorem. Sine square plus cos square is 1. This is, we derived it in using Pythagoras, basically, right? And if you rearrange the terms, so 1 minus sine square is cos square, 1 minus cos square is sine square. And 1 plus tan square is secant square minus tan square is 1. So always remember, whenever you have a square minus b square, you can express it as a plus b times a minus b. All this is basic algebra, and I jotted down a couple of algebra formulas too. Likewise, 1 plus cot is cosecant square, cot square is 1. And when you multiply a square minus b square, you can express it as a plus b times a minus b. Multiply, it becomes 1. All right. These are pivotal, very, very important concepts in algebra we might have studied. A plus b whole square, a minus b whole square, expansion. This you must remember, because the application are in simplification, you use all these basic algebra quite a lot. Now, a square minus b square, a plus b times a minus b, a plus b whole cube, a minus b whole cube, all this, and a square. What's the difference between this and this? We are expressing this, a cube plus b cube, as factors. A plus b times a square minus ab plus b square. Likewise, a cube minus b cube is a minus b times a square plus ab plus b square. All right. Now, this is a cheeky little one. Whenever you add a plus b whole square, a minus b whole square, you get 2 times a square plus b square. Remember this. Okay, let me just confirm with if I'm recording this. Yeah, I am indeed recording, because last week I did a hideous mistake. I was doing a bunch of stuff, but I stopped pressing the record. Anyways, a plus b whole square, a minus b, okay, the cheeky little one I said, right? A plus b whole square plus a minus b whole square is 2 times a square. This is, and when you subtract both, remember, it's 4ab. This is quite handy, and sometimes, and believe me, you memorize these formulas, practice them, it'll save a ton of time, especially in competitive exams. You can do it really, really fast. Okay, now I'm going to solve a couple of problems in trigonometry. What kind of problems you expect? One of them is typically, I would categorize as this. One of them will be like solve it or simplify. Let me just use the black. Simplify, evaluate, etc., etc. This fancy little jargon, but ultimately it means simplify. The other kind of questions you expect is prove that, show that, etc., etc. So what it means is, he gives you an equation, you got to prove that the specific equation holds value, holds true. Yeah. Let me solve. Okay. First question. Tan theta plus cot theta is secant theta times cosecant theta. He's proved that. This is a typical equation. It's a small equation. He's telling us to prove that the left hand side, when you simplify, becomes right hand side. Left hand side and right hand side are equal. So this is the left hand side. This is the right hand side. RHS. Right? So we're going to take left hand side. We're going to rewrite it. And we will manipulate it, massage it, do whatever we want to do, as long as we follow the mathematical laws. And we arrive to the right hand side. Okay, let me rewrite this. This symbol is called implies, remember, okay? Imply. I'm just going to rewrite the first statement, cot theta. And if you look closely, the answer is in terms of secant and cosecant. So we have to express this in sine and cos. So I'm going to express tan theta as sine and cos. Tan theta is sine theta over cos theta. And cot theta is cos theta over sine theta. Okay, now this is, if you treat this as a simple fraction, you can add two fractions. How do we add two fractions? Let me quickly tell you how to add two fractions, right? Okay. Typically, adding two fractions, this is not an algebra class, but I just want to show you a quick trick. Okay, quick. 5 by 4 plus 3 by 2. 3 by, say, 5. Typically, in some countries, you add this, make it equal fraction. So to make it equal fraction, you can find the common multiple, which is 20. Then you multiply with 4, multiply with 4, multiply with 5, multiply with 5. Okay, so this becomes 20, and this is 25 plus 4 is 12 over 25 was 20. So this ultimately becomes 25 plus 12 is 37 by 20. Okay. This is okay, but you tend to waste a lot of time by writing all these little things here and here, and it takes little time. Instead of this, if I tell you a cool way to do this is write this as it is, 5 by 4 plus 3 by 5. All right. First, take the product of these two. Multiply the denominators. Take product of these two. 5 was 20. Write it like this. Now, multiply this across. 5 5 is 25. Then use the plus symbol. If it's a plus, plus. If it's minus, then you write minus. 4 times 3, 12. This is 37 by 20. This is way faster. And you don't need to write all these things. All right. Now, this is especially useful. This trick is especially useful when you have variables. Say, for an example, if I have something like this, 3 by A plus 2 by B. How do I express this? Take the product, AB in the bottom. Now, multiply. 3 times B is 3B plus 2 times A, 2A. So, ultimately, this resolves to 3B plus 2A by AB. All right. Now, if the fraction is like simple like this, 4 plus x by y, this is it's a lot simpler in this case. Same thing. Multiply this, 4 times y, 4y plus x divided by y. This times this. Basically what it means is there's a 1 underneath, and we use the same principle above, but you don't need to write again 1. Okay, for this times this plus this. Okay, now we can apply this here on the left side. We have sine theta over cos theta over sine theta. Common multiple is sine theta times cos theta. All right, now multiply this, multiply this. Sine theta times sine theta is sine square theta. Sine square theta plus whatever the operation in between. Cos theta times cos theta is cos square theta. Now recall the Pythagoras theorem. Sine square theta plus cos square theta is 1. 1 by sine theta times cos theta. Now recall the reciprocal of sine theta. This is what? This is a reciprocal, 1 over sine theta. Okay, we can rewrite this as again 1 over sine theta times 1 over cos theta. Alright? What is 1 over sine theta? 1 over sine theta and 1 over cos theta. 1 over sine theta is reciprocal of sine theta is cosecant theta times 1 over cos theta is secant theta. So what do we notice here? We have it as cosecant theta times secant theta, which is equivalent to, is same as secant theta times cosecant theta. Now if you look closely, we have arrived to the desired result, right hand side. So what it means, we prove that this is equal to this. Understood? Pause the video, take a look, understand, try to do it yourself. Practice, believe me, practice. If you practice a lot, you start getting ideas. Okay, let me do the second problem. All right. The problem number 2 is prove that, same thing, it's similar. Prove that tan square alpha plus tan 4 alpha equal to secant 4 alpha minus secant square alpha. All right, this is the left side, right side. It's funny, right? You can prove, you can take the left side expression, arrive to the right side. Likewise, you can take the right side expression, arrive to the left side. Either ways, you prove that the above equation is valid. Okay, let me just do this. Now, if you look closely, the answer is in terms of secant. The question is in tan square. Recall the formula which deals with tan square and secant square. Okay, I'm going to write it here. If you look, 1 plus tan square alpha is secant square alpha. All right. So I'm going to express tan square alpha in terms of secant square. Tan square alpha will be what? Secant square alpha minus 1. You have to memorize this. Believe me, it will save you lots and lots of time and confusion. Just memorize these formulas. The grid above I mentioned. Tan square alpha. So I'm going to write this tan square alpha in. First things first. Let me just, because the square here, there's a 4 here. Let me take the greatest common factor and see. I'm going to take the greatest common factor as tan square alpha. So I'm left with 1 here plus tan square alpha. You should be familiar how to take greatest common factor. Okay, because it's a common factor, greatest common factor between this and this. And if you verify, you multiply inside, tan square times 1 is tan square and tan square times tan square is tan square. You arrive to the previous step. Okay. Now 1 plus tan square I'm going to replace with secant square. Tan square alpha times secant square alpha. And this tan square alpha I'll replace with secant square alpha minus 1. I can do the same thing in single step basically, but that's fine. I'm doing it in 2 steps. So tan square alpha, I'm going to write it as secant square alpha minus 1. Secant square alpha minus 1 times secant square alpha. Alright. Now the secant square alpha I'm going to multiply inside. Secant square times secant square is secant 4 alpha minus secant square alpha. So looks like we reached our destination. They match. So we proved the above statement is true. Now pause the video. Do me a favor. Take the right hand side. Secant 4 alpha. Pretend this is a different question, right? Prove that. secant 4 alpha minus secant square alpha equal to tan square alpha plus tan 4 alpha. You try this, right? It's pretty similar. You express, first take the greatest common factor, then instead of secant square, write in terms of tan square. You can write secant square as 1 plus tan square and try it. Okay, now I'm going to solve another problem. He's telling you, show that root 1 plus cos alpha divided by 1 minus cos alpha equal to cosecant alpha plus cot alpha. Okay, now recall, in algebra you might have studied a concept called rationalization. I'm going to quickly go through one simple rationalization problem. So if you have, what is the rationale behind rationalization? Back then, before all these calculators and things invented, all the mathematics was done using hand. All hand calculations were done. And if you recall, if you study interesting topic called logarithms, you can Google around. It's pretty interesting how Napier discovered. I get confused with discovered and invented. I think it invented this Napier algorithms, like Napier logarithmic tables. Okay, let's come back to business. Okay, now what I mean by rationalization is, say for an example, dividing with irrational number, 2 divided by root 3. This is a Herculean task because 2 divided by 1.732, which is root 2, it's quite complex. Rather than this, if you rationalize, means what? If you multiply and divide with root 3, you're not doing any violating mathematics. All we are doing is adding and multiplying with root 3. So this would resolve to 2 root 3 divided by 3. And root 3 is 1.732. 1.732 times 2 is some fraction, that's some decimal. And dividing this with 3 is fairly, say for an example, 1.732 is, say, times 2, right? 2 2 is 4, 3 2 is 6, 7 2 is 14, 2 1s 2 and 3. 3.46, something like that. So 3.46 is very easy to divide with 3 rather than 2 dividing with root 3. So this concept is called rationalization. Now, if we have a fraction like this, 3 divided by root 5 minus 2. So you multiply and divide with rationalizing factor called root 5 plus 2. Root 5 plus 2. This is the rationalizing factor of root 5 minus 2. Why? Because when you multiply a minus b times a plus b, this will become a square minus b square, which is in the denominator. It becomes root 5 square is 5, 2 square is 4, 5 minus 4 is 1. So basically this whole complex irrational fraction becomes nicely 3 root 5 plus 2. 5 minus 4 is 1. This you can easily do manually. So this whole process is called rationalization. Okay, we're going to apply the same concept here. Apology for jumping into algebra. Just wanted to make you clear. Okay, now I'm going to write this root, a giant root. Okay, and I'm going to multiply and divide this cos alpha divided by 1 minus cos alpha. I'm going to multiply and divide with the rationalizing factor 1 plus cos alpha. 1 plus cos alpha divided by 1 plus cos alpha implies, okay, if in the numerator 1 plus cos alpha whole square, it's quite obvious, divided by a plus b times a minus b is a square minus b square, 1 square minus cos square alpha, and there's a root, a giant root. Now giant root again, 1 plus cos alpha whole square. 1 minus cos. 1 square is 1. 1 minus cos square alpha is sin square alpha. Implies. Now, this is a square root of a square. The square disappears, right? Root of a square is a. So this would resolve to 1 plus cos alpha divided by sin alpha. Now split the fractions. This would resolve to 1 by sin alpha plus cos alpha by sin alpha. What is 1 over sin alpha? 1 over sin alpha. Reciprocal of sin alpha is cosecant alpha. Cosecant alpha. All right. Now cos over sin is cotangent cot alpha. So what do we have here? We arrive to our destination. From here, we rationalized it. We applied basic algebra. That's all we did. All these fundamentals you would have mastered in algebra. Believe me, if you have any hint of element of confusion, go back to algebra, practice a little bit of problems, and come back to trigonometry. So, and I see that solving trigonometry problem is again doing a lot of massaging of algebra, right? Okay, let me solve one more problem. Go up, solve one more problem. Okay, now this problem is, it doesn't tell you what to prove, etc. It's telling you simplify. Simplify. What do we simplify here? Okay. Secant square alpha minus 1. So I'm being very, let me just use some other calculator. Let's justify beta. Secant square beta minus 1 times cosecant square beta minus 1. He's telling you to simplify this. Okay. Now recall the formulas which involves secant square. One thing comes to my mind is 1 plus tan square alpha, which is secant square alpha. Let's say beta. Let's be taking beta. 1 square tan square beta equal to secant square beta. So what is secant square beta? I can express it as, oh yeah, I can move this one here. So tan square beta equal to secant square beta minus 1. What do you understand? What do you mean by moving? It's basically what I did is I'm subtracting 1 both sides. That's all I'm doing. And these two cancel off and we'll be left with this. Okay. Tan square beta is secant square beta minus 1. All right. Now I'm going to, likewise, his counterpart, cot square beta is cosecant square beta minus 1. I'm going to replace these two fellas here. So secant square beta is tan square beta. Cosecant square beta minus 1 is, this one is this, cot square beta. What is the product of tan square and cot square? Tan and cot are reciprocal of each other. Whenever they come together, they cancel off. Becomes 1. So the whole expression, this complex expression, resolved to 1. In my class, I give a funny analogy. Okay, tan beta times cot beta. If they always kind of like, I shouldn't say word kill. They kind of like offset each other. One of them is mother-in-law of others, like mother-in-law and the what do you call it as daughter-in-law. If they sit together, what do? They want to smash each other, something like that. They always cancel off. Okay, let me solve problem number 3. It's a joke, okay? Don't take it literally. Number 4. secant A 1 minus sine A secant A plus tan A. Okay, simplify this. It's telling you to simplify. How do I do this? Okay, let me express everything in terms of sine and cos and try. Secant A, I can write it as 1 over cos A. This is 1 minus sine A. I can express this secant A as again 1 over cos A. Tan A as sine A over cos A. Alright? Now, this I rewrite again. Implies 1 over cos A. I'm not going to touch these two. 1 by sine A as it is. Now here, what do we have? 1 plus sine A by cos A. 1 plus sine A divided by cos A. I think we're going somewhere. It's becoming warmer. Now, if you look closely, A minus B, A plus B. As I've told you, A minus B times A plus B, A square minus B square is notoriously used pretty much everywhere. Okay, this is A square. It will evaluate to 1 square minus, in the numerator, sine square A. In the bottom, cos A times cos A is cos square A. Implies 1 minus sine square A is cos square A divided by cos square A. So what do we have here? Ultimately 1. So this complex algebraic expression became simple number 1. All right. Now do one more problem. Okay, he's asking us, show that again. Okay, show that one minus tan square beta divided by cot square beta minus 1. You can pause the video, come back, look at the solution. He's telling you to prove that or show that this evaluates to tan square beta. If I can express tan square beta in terms of sine and cos, let me try that. So implies 1 minus sine square beta divided by cos square beta. This is cos square beta divided by sine square beta minus 1. Okay, let me tell you one simple statement. In mathematics, you can skip any number of steps and just do in any way. I mean, what I meant to say is there are several ways, but when you're presenting it, if you present it nicely like this, just an example, it becomes very readable. If somebody borrows your book, he will understand, okay, this is happening algorithmically, nicely. Flow, it should flow. Like it's, in a nutshell, your problem should be like a story. Understand? Anybody can understand. And in future, say for an example, 5 years down the line or 10 years down the line, if you look at your book, you should be able to understand, and you can teach your kids. Anyways, now this is a simple fraction here. Okay, I'm going to, as I've told you, fast way to do this is cos this times this minus this. Cos square beta times 1 is cos square beta minus sine square beta divided by cos square beta divided by cos square beta minus sine square beta divided by sine square beta. Right? What I did is, this is multiplied with this minus this divided by this. Simple fraction. Let me reiterate. 1 minus x by y. How do you do this? You can write it as 1 by 1 minus x by y, but this is redundant, but I'm just telling you. This times this times this. In the denominator, just times these two. 1 times y is y, y times y minus x. All right? So likewise, cos square beta times 1 is cos square beta minus sin square beta by cos square beta. This one, like this is sin cos square beta minus sin square beta by sin square beta. All right. Now, if you look closely, these two fellows are same. They can cancel off directly here itself, but I'm going to rearrange this. This is a simple fraction. Simple fraction. The numerator is a fraction, denominator is a fraction, fraction over fraction. What is fraction over fraction? Say for an example, 1 by 5 divided by 3 by 2. This will evaluate to 1 by 5 times 2 by 3, which will evaluate to 2 by 5 times 3, 15. All right. Now, this fraction, we're going to rearrange this as cos square beta divided by minus sin square beta divided by cos square beta times this. When it goes up, it flips, sin square beta divided by cos square beta minus sin square beta. Okay, these two fellows nicely cancel off. Now we are left with what? Sin square beta by cos square beta is, sin over cos is tan square beta. Let's see what is, yeah, he's telling you to prove that this is tan square beta, this is tan square beta. So we proved it. Got it? Okay, let's do one more problem, right? Okay, this looks quite daunting, but let's find. Let me see. Sin A plus cosecant A whole square plus cos A plus secant A whole square. He's telling you to prove that. Okay, prove that. This equal to 7 plus tan square A plus cot square A. Okay. Let me, first things first, I'm going to expand this. A plus B whole square. What is A plus B whole square? I'm going to write here on the side. A plus B whole square is A square plus B square plus 2AB. Remember that. All right. Okay. This is expand this. Sin square A plus cosecant square A plus 2 sin A cosecant A. All right. Likewise, this one on the right side, this guy, cos square A plus secant square A plus 2 cos A secant A. Okay, the moment I see sin and cosecant A, they are reciprocal of each other. They cancel. The product becomes 1. Likewise, cos A secant A, the product becomes 1. So what we get is sin square A plus cosecant square A. This becomes plus 2 because the product is 1 plus cos square A plus secant square A. This product becomes 2. So what we have is 2 and 2 we can combine, becomes 4. Now look closely. Sin square A and cos square A and plus sin square A plus cos square A is 1. All right. Okay. We're going to write this instead of this. These two combined, we'll write it as 1. 1 plus, we are left with cosecant square A plus secant square A plus 4. All right. I'm just bringing him closer instead of over here. Okay. Plus 4. All right. Now, if you look on the right side, the answer is in terms of tan and cot. And there's a 7. So far, we have a 4 plus 1, 5 plus cosecant square A plus secant square A. I think we're becoming warmer now. We need 2. We are short of 2. Okay, and the answer is in tan and cot. So we will express cosecant square and secant square in tan and cot. Recall the formula. 1 plus tan square A equal to secant square A. So I can express cosecant 1 plus cot square A equal to cosecant square A. I'm going to replace these two here. Instead of cosecant square A, I will express it as 1 plus cot square A. 1 plus cot square A. And secant square A, express it as 1 plus tan square A. Implies. Now we do the basic arithmetic. 5 plus 1 is 7. Plus we have tan square A. I'm writing tan square A in the first. Plus cot square A. What do we have here, bro? I'm sorry. What do we have here? So we arrived to our destination. Correct? Now I'm going to do one last problem and we'll wind up from here. Okay, remember this. As I have, back when I was studying, I practiced a lot, especially I love trigonometry. You practice a lot. Then believe me, later part of trigonometry becomes really, really fun, especially cosine law, sine law, Heron's theorem, heights and distances. They're pretty interesting problems you can solve. Okay, let's come back to this question, last question. Okay, say he's giving you cosecant theta plus cot theta equal to P. He's given you the statement. He's asking us to find cos theta, sine theta, and all other ratios, cot theta, etc., etc. Okay. How do I do this? Okay, remember in the formulas I gave you, right? Cosecant theta plus cot theta. Whenever we have cosecant theta plus cot theta, what is the formula deals with cosecant and cot? 1 plus cot square theta equal to cosecant square theta, right? I can move this here. I can write this as cosecant square theta minus cot square theta equal to 1. This is basically the deal maker here. So this is given fact, right? This is a formula. I'm going to write the formula here. Cosecant, this is the known fact, cosecant square theta minus cot square theta equal to 1. This is known fact, right? We know this. Now I'm going to express this as a square minus b square as a plus b times a minus b. So this is cosecant theta plus cot theta times cosecant theta minus cot theta equal to 1. A plus b times a minus b. Now I will replace this here. Instead of cosecant theta plus cot theta, I'm going to write p. Alright, so this will become what? P times cosecant theta minus cot theta equal to 1. So cosecant theta minus cot theta will be 1 over p. Correct? So we have two little simultaneous equation. One. This one. What do? We'll try to solve the simultaneous equation by elimination. I'm going to put them side by side. Solving simultaneous equation by elimination, substitution, all this little things you might have studied in algebra. If not, go back and refresh it. Okay, I'm going to put these two equations side by side. Again, I'm going to rewrite again. Okay, because it's already here, I'm just writing the equation number 1 below this. Cosecant theta plus cot theta equal to P. These are the two equations. When I add these two, cot and cot will cancel. We can eliminate cot. So 2 cosecant theta equal to P plus 1 by P. 2 cosecant theta equal to P square plus 1 by P. Correct? So cosecant theta is P square plus 1 by 2P. Now, draw a little right angle triangle. What is the definition of cosecant theta if this is theta? In terms of sides, hypotenuse, this is hypotenuse, this is adjacent, this is opposite. Cosecant theta is what? Hypotenuse over opposite, right? So in this, if equivalent hypotenuse, if hypotenuse is P square plus 1, if this is P square plus 1, opposite will be 2P. Now using Pythagoras, find what is adjacent. Recall what's Pythagoras. Pythagoras is opposite square plus adjacent square equal to hypotenuse square. So we want adjacent value. So adjacent will be what? Square root of hypotenuse square minus opposite square. This is all basics. Okay. So I'm going to find out hypotenuse. Adjacent, sorry. Adjacent would be square root of hypotenuse square, which is P square plus 1 whole square minus opposite square. Opposite square is 2P whole square, which is 4P square, basic algebra. Okay. Here, this is A square minus B square. Okay, one second. I'm going to express this again. P square plus 1 whole square minus, this is 2P whole square. Alright? Implies, I'm going to evaluate this. A square minus B square is A plus B times A minus B. Square root A plus B times A minus B. Okay, this whole thing is square root. Instead of giant square root, I just used a bracket. So this will evaluate to root. If you look closely, this is A square plus 2AB plus B square, because 1 is what we can write 1 as 1 square. 1 square. This is A square plus B square plus 2A. This is a hidden one. P is P times 1. This is a hidden one. Hidden. So this is basically P plus 1 whole square. This is P minus 1 whole square. A plus B whole square. Understand? If you are confused, pause the video. Go through this. P square plus 1 square plus 2 times P times 1. P plus 1 whole square. So this is P plus 1 whole square. This is P minus 1 whole square. Alright? And square root. So square root of P plus 1 whole square, P minus 1, the root disappears. It will be P plus 1 times P minus 1. Which implies, again, A plus B times A minus B. A square minus B square. 1 square is 1. Correct? So what do we have? Go back to this one. The right angle triangle. Adjacent is equivalent to P square. Rewrite what is adjacent. Adjacent would be P square minus 1. I'm going to use a green pen. That's fine. P square minus 1. So now we have all sides of triangle. We can find any ratio. In the question, he's asking what is sine theta and cosine theta, cot theta. I'm going to copy this. One second. I'm not quite good at using this surface thing, you know. Okay. I'm going to put it here. Okay. Now we want cos theta, right? All right. Cos theta would be adjacent over hypotenuse. So cos theta will be adjacent, which is p square minus 1 over hypotenuse is p square plus 1. Now, what is cot theta? Cot theta is adjacent over opposite. Cot theta is adjacent p square minus 1 over opposite 2p. So you can find any ratio. Got it? Okay, let me end this class here. And in next class, I'm going to come back and do more problems. All right? Salute. Hasta luego. Goodbye.